So we're here from Joshua Tree National Park in California, just north of Joshua Tree itself. And we're going to do a field report because when I got here, and I've been here for about a week now, my number one sense of the place is, my God, this is a giant pile of rubble. I mean, it is small rocks, as if somebody, just dropped rubble here. And what we're going to do is we're going to look at some of the rock formations and look at what they look like, and examine these really fascinating hills, and why we might find large rocks on the top and sand on the bottom. Because if this was the bottom of an ocean, then the heavy stuff falls first. But that's not what we're finding. We're finding large rocks left at the top, as if the small stuff fell away from the large stuff over time. And in fact, they have a display down in the visitor center that kind of talks about the fluvial flows that occurred. Well, yeah, the rubble here, I think, represents what we find in the mythology, for example, of Athena and Pallas, Venus, which is that Athena wears the skin of her victims. And I get the sense that what we're looking at here is we're looking at a surface that is covered with the rock and remnants of the surface of the planet Venus during the apocalypse. One of the things to address right off the bat is the existence of fossils within the park. To place the fossils in their proper context, we need to note that, quote, chemical analysis of fossils provides an account of past global temperatures, ocean acidification, and asteroid impacts. Acidic oceans and an impact is a description of the changes that happened on Venus as the apocalypse set in, and the fossils are the remnants of life that used to exist on the surface of the planet Venus prior to its final destruction. The animals fell from the surface of Venus with the rubble to the surface of the Earth, and they ended up mixed with the surface matter. These megaflora and megafauna creatures include mammoth, camel, horse, llama, pronghorn antelope, bison, dire wolf, giant ground sloth, and even the saber-toothed tiger. Some of these species may have even survived in the area for a time afterwards. It's noteworthy that not a single complete megafauna animal has been found among the fossils, just bits and pieces, like the tooth of the dire wolf. They only found part of a tooth. Where's the rest of the animal? Just as the surface of Venus was ripped away and exposed to the electromagnetic forces of the two magnetospheres, these animals were torn from the surface of Venus and then into pieces, where only parts of their bones fell to Earth and were scattered among the soil and later found. Of substantial note, not a single dinosaur bone has been extracted from the area. That's because the environment where they lived is now buried between a few thousand feet of sand and hardened mud that covers the area. So we're on the Bigfoot Trail here at Joshua Tree, and I want to start by just kind of looking at this very first outcrop. It's a small, low outcrop. It doesn't take anything to get in here, but just to kind of look at what we find on the rocks in just this outcropping. And these are basically, I think they define them as granite, but we've got these striations that go through all of them. And then, these very straight, flat edges. And I don't have much of an idea of how you would form these, other than the fact that, this reminds me of chunks being lifted up. And, just like the Earth was originally layered clay, so was the surface of Venus. And so if these represent the rubble, the remnants of a surface that was pulled down upon the Earth, what we're looking at is we could be looking at the striations of the original planet. But then again, we could also be looking at rocks that were formed as just chunks of mud. And if they're chunks of mud, I'm convinced that we're going to find evidence that suggests that. Part of the idea is, you look at rocks like this, where we're not looking at, things that landed flat, but still show these striations. And so, do these represent something else? Do they represent the rock fracturing as it landed? Because it's just fractured rock at this point. You've got, giant rocks down here. They have straight, flat edges. And there has to be a reason for these flat edges. There's another one right here. And, some of these have, big holes. There's a giant hole in there that you could probably stick like a softball-sized object in. Where do these holes come from? Where do these line striations come from? And the answer might be as simple as saying that at the very end of the apocalypse, there was a mass cooling event. Because I see these same types of lines at the park at Rib Mountain in Wisconsin, where you have these nonlinear line breaks all over the place. And if you said, hey, Bob, where else do you see these? Well, I see them when I stick an ice cube in a glass of water, and the ice fractures. And so we could just be looking at a fracturing of the rock during one of the phases of the apocalypse. We're going to look at a couple other rocks around here. Hang on. So here's another example of why I really feel like this looks like rubble. And that is that this rock up above here has an orange characteristic to it, and the one below it has a gray characteristic, and this rock sits on top of this as if it was deposited here. Now, someone might argue, Bob, glaciers deposited all this, or they might say that this was part of an ocean that just deposited from waves. These are massive rocks, and it seems almost indicative of the rock to suggest, look, I mean, I'm probably the first person to ever touch this rock, and yet it sits ever so delicately right under here. Where did this rock come from? That the rocks under it would have this same, right? Once again, we're talking about layered rock. And so was this mud that vitrified and turned into a granite substance as it came down, leaving other rocks piling on top of it? That's the question. And so this is the last few rocks at this area that I'm going to explore. But I stopped here because one of the things that just is fascinating is that although these look like extremely hard rocks, much like I find in Wisconsin, right? These rocks are just conglomerations of the sand you find all around here. They look more like just boulders of accumulation. Not that they were even a solid piece of ground at one point, but rather became solidified into this rock during the event. I mean, I can just running my hand along here, I can get, small samples of this, and this rock is indistinguishable from the sand around it. And so what I'm suggesting is that all of this sand is just the same as all of this rock. And all of this rock is just rubble. Rubble that went through the two magnetospheres and the forces of electromagnetism, the heat and the forces of electricity, baked it. Let's keep looking.
I'd like to say that I'm the first person who suggested that the surface of Venus rests on the west coast of North America. But that distinction goes to Andrew Hall and his 2017 Electric Universe presentation. Here's Andrew Hall not only suggesting this, but his description of the winds, which sculpted the west coast.
Now, in a Velikovsky-style electrical event, whatever the causation, whether it's Venus or a solar flare, and some external perturbation to the electrical balance here, what would happen is that these currents, internal and outer mantle current, will push apart and pull together. There's Lorentz force that's going to occur. And if they push out, then they push out into the crust. So what I'm proposing is that these currents get pushed out into the crust and melted, creating large shield volcanoes. And that essentially is what forms the cratons that underlie the continents. So by doing that, I was able to do a wind map for the entire continent, or the orogenic belt portion of the North America. And what it shows is that there's two inflowing winds, one from the south and one from the north. And they come in and they wrap around in a counterclockwise multiple vortex system. So the first wind comes from Mexico, and it comes in and it wraps around counterclockwise over the Colorado Plateau. Then this wind comes in from Alaska and pushes its way in around the arc of the mountains of the Sierra Nevada, and then wraps around in a counterclockwise fashion in a vortex centered over Salt Lake City. And then there's a third inflow that comes in, wrapping around from the east and flows over Wyoming and Montana. And then in between, there's this red line, which is a ridge. It's a pressure ridge for the shear zone between these three vortexes. And it forms this S shape, and then it shoots out a tendril here between this Montana jet stream and the Colorado Plateau jet stream. Then there's a fourth jet stream that's just forming. It comes in over the LA basin over here from the west, and then it wraps into the rotation over the Mojave Desert.
What Andrew Hall is describing along the west coast of North America is called an inverted hysteresis, which forms this backwards S-shaped curve. While the inverted hysteresis formed this backwards S and gave definition to the landmass, traditional hysteresis formed like a regular S-shaped curve, which gave definition to the east coast of Asia. These two worked in tandem, and to extend on what Andrew said, as Venus pushed down here in the crust at the Tarim Basin, causing a negative charge, opposite the negative charge was the positive charge forming the west coast of North America. This incoming positive charge is what formed the high desert and mountains of the entire west coast of North America. The positive charge represents positively ionized material coming down in shock waves. The shape of the positive charge is called the Lichtenberg figure, which can be easily seen in the tops of the Sierra Nevada mountains. These shapes exist because of an incoming positive charge, and that positive charge included all the material being drawn away and pulled from the surface of Venus. One of the things that Andrew Hall talks about in his videos, in particular his video Cracks in the Theory, he talks about how the electromagnetism of the event layered the rock. And this could be probably one of the primary reasons we see these, straight line striations in the rock. But I mean, look at this. This is a completely different morphology of rock on the outside, or rather on the outside here where it cracked, than you find elsewhere. These are almost two different kinds of rock, and the only way you get that is through, electromagnetic forces. One of the reasons I say we may be looking at rubble, right, that came down, is that you have this one here has a line that goes in this direction, but you have the exact same type of line striation of this rock, this crystallization, probably a quartz, in additional boulders, but they're not in a row. They're not lined up. It's as if at one point they were lined up, but they landed in slightly different orientations. Yeah, here. We've got another line right back over here. And again, they're not in perfect line, as if they were at one point when it happened. Here, we've got more of that same stuff right up here. Look at that. Right, so these are electrical changes that morphed the rock. These may have all been in alignment as they fell, and then fell into these current locations.
We have these weird granite striping going through here, and why would that be caused by erosion?
Yeah. It suggests that the rocks came together to form what they formed, and there were electrical forces moving through them. And you've got another one. This one's at a right angle to this one, right? In fact, this is kind of interesting.
This is almost polished over here.
There's a whole line that goes right through here. Makes you wonder how much of this came down in one single swipe. And this is a fairly large and flat piece.
No, it's a scaled up version. This is a factor bigger than this one.
Right.
It's the same shape. It's just an order of magnitude larger.
Well, in the bottom rock here, so what Daniel's saying is that the rocks here might just be scaled from themselves. But, you know, the rock that's on the ground here has more quartz in it than the one up here. As if they came in as two different rocks at, at different times. Maybe of course, during the same event, but that this one represents something that came down first, and this one landed on it. These landed on it. In fact, hang on. You really get that sense when you look at this rock right over here, which is just sitting here. How do you plant that one? Did somebody come over here and decide they were going to lift it and set it there? Of course not. But oddly enough, I bet if we moved it, we'd find the bottom side of it is flat.
It's entirely different than this surface. This edge is polished right here.
Yeah.
I mean, naturally polished, obviously.
And, this isn't the only, there are several different rocks like this, but here's another example where this one came down and clearly split from the rock next to it.
You see clear splitting?
Yeah, well, I mean, the two sides of the rocks are identical. They're sitting next to each other, and they actually have a similar shape as if they were connected at one point. And yet there is a rock sitting right in between them.
Like it was.
Yeah, look at so you've got giant splitting between these rocks. I'm really more and more of the mind that the splitting is caused by the supercooling that perhaps happened right at the end of the apocalypse. And it caused a lot of the splitting that we see because the splits seem to have occurred while they were sitting in place. And then you have these interesting, boluses within this. There's a giant bowl in here. This is similar to what I found earlier. How did you form? Don't say glaciers. Glaciers don't make the completely flat edge that this rock has. This is completely flat. So one of the things that we're noting is that, is it possible that the rocks shattered when they hit? And if you look, that this rock on this top side over here, let's see if I can get my finger in here, this rock on the right has a formation that matches the shape of the rock below. As if it may have fractured and split when it hit. But boy, the force between these two, it almost seems like it popped. As if after it hit and then super cooled, if you've ever seen, I did this once, I accidentally put a hot glass lid under cold water and it fractured, it went pop. And that's almost what we're looking at, because this rock on the left, this rock over here, is clearly part of this rock on the right, and it looks like it may have occurred that it just was moved by a massive force of cooling, popping it at the moment. In fact, look at this. Look at this. That suggests high heat and something, causing a change in the surface. Radial change.
Yeah, so when I look at these rocks and you see they just break apart pretty easily, they remind me of going to the beach and pouring water on sand and letting it bake in the sun a little bit. It turns into like a lightweight sandstone. And I mean, this whole thing right here, if I pulled hard, it would fall off. I don't want to disturb the nature that much, but if you look at the bottom of this thing, it's totally flat. And how does something erode in this manner? It looks more like it was stacked, the stack as it fell to earth.
So one of the reasons that I think what we're looking at is a surface that cracked after it landed is that you've got this this giant hill over here that's full of what I'm calling rubble. And there is a surface crack almost perfectly through all of the different rocks all the way down. It's not individual rock fracture. It's a fracture down the middle of all of the rocks. So one of the things I want to be clear about, and I've kind of said it a number of times, is that, it seems that these rocks were placed down in the apocalypse, rubble falling onto the surface of the earth. These rocks then experienced a large amount of erosion. One of the things about catastrophism is that, we believe in both the very quick change that caused the surface to be, covered in rubble, but we also believe in the uniformitarian principles of erosion. This rock has clearly gone through erosion. I mean, just touching the rock, it's eroding. You can tell that it's experienced that. But again, it's just a conglomeration of all of the sand you find around us. As if this sand is the stuff that didn't clump together, and the rocks are rubble that did clump together. I don't know how else you get this except to say that these rocks came down and, part of the rock eroded away and left this rock just kind of hanging here because it was otherwise planted here in this condition. And I don't think that's the case. I think parts of this rock were not as solidified as other parts. And you've got these now perfectly balanced rocks in an arch. This is fascinating. Let me take you a little closer on this one. And then we're going to look at another rock in the area that shows an example of fracturing that doesn't match this, these straight striation fractures that we find everywhere. So just around the corner from the arched rocks, we have this giant boulder. And you'll notice that although this one has cracks, these are more like the cracks you find when water gets between cracks and then freezes and creates the cracking formations. These aren't straight cracks. These are more like standard uniformitarian cracks you get with, water erosion that freezes, expands, cracks the rock. And one of the things we wondered is whether or not this rock rolled into here and this is why it cracked, but this rock is sitting directly under this other giant boulder next to it. And so these have both been here since time immemorial. These were here at the end of the apocalypse. And then we're looking at on these is the outward erosion on the surface, which eventually on that rock allowed water to get in the inside and probably froze during a very cold night. Maybe, not long after the event itself.
This again looks like the sand at the beach that you make, and it just had enough, probably electrical energy to hold another glop of sand together. It's very interesting.
Hey, you've got, I always wonder if the red on the bottom is iron, of an iron deposit, or what exactly causes that browning. But, clearly we're looking at something that layered. One of the things really worth noting is that, these are all sort of standalone large block rubble piles, but the mountains just behind me are all made up of much smaller conglomerations of rock. These are the large rocks, and those are all made of small rocks. So there's got to be a reason that there's a differentiation, because if you're going to say this was all formed under one general regime of uniformitarianism, whether it be glaciers or oceans or whatever you want, well, it should all be relatively the same to some degree. But this area where we're standing right now is completely different than the mountain that stands behind us. So this rock outcropping right here really caught my eye, because you can just see how all of that is sculpted in a single way, as if something created this broad wide edge of a cliff, but out of these disparately separated rocks.
What you got to do is you got to show this shot, and then you got to show the rocks where it's split open on that scene.
Mm-hmm.
Because this.
So we're further into Joshua Tree Park here now, and I can't help but feel even more like what we're looking at are chunks of the surface of Venus being lifted up and just splashing down on Earth as whole chunks of just mud that, of course, then solidified into rock and sand. And, you can see that because these are all single rocks that have only experienced erosion. But let's take we're going to do a big loop picture here of everything in the area. And right behind us, you're going to see this rock that just stands alone. It's just a huge, huge rock. And then we're going to come back to this shot here, because, you look at this one, this mountain behind us here, and you've got, once again, these just near perfect straight lines going right through the middle of it. And then at the very top, there's actually an opening. And that opening is likely caused by erosion over the years. But it exists because the electrical etching or the cooling or whatever it was that formed the striation in the rocks weakened it. But once again, we're just looking at a rock that was sucked up, dropped down here in the middle of what we now call a desert. So we're on the north side of the park. We're still in the park, but when we look at these rocks, these have undergone much more heat, much more vitrification. They're red, they're burned. And not only that, but we have a lot more rubble, right? And if you crack one of these rocks open, you find that, we're really looking once again at the same type of sand as we had up down south of here, except this sand went under more baking, went under more crystallization and more solidification. But it's still the same basic process. It's rubble. We're just dealing with rubble from the surface of Venus as it went through the dielectric process of hardening and vitrification during the apocalypse. And so what I think we're looking at here is the same process as the Tunguska meteorite that exploded over the area. What happens is that the meteor presses down on the magnetosphere. But in that case, when the magnetosphere lifted it off, it caused an electrical discharge from the surface of the Earth. What happened here is like a spaceship reaching escape velocity, except it reached penetration velocity. There was so much pressure that it began coming through the Earth's magnetosphere and planting itself here in what we now call Joshua Tree National Forest. And it's a beautiful place to visit. I recommend you do. And when you get here, I don't know how you don't have the same sense of it that I do. It's a giant pile of rubble from the surface of Venus. Don't forget to click that like, share, and subscribe button for all the latest in catastrophism research. Peace out, everybody.